So an explicit form, actually formula, or form, doesn't really matter. So an explicit formula for a sequence A1, A2, or I'll start at M. AM plus 1, out to AN. An explicit form for a sequence like this is just going to be AI equals f of I for all I greater than or equal to M, where this f of I is a function that only depends on I. And by that I mean it only takes in an I. And so notice that in our example here, where we had the even numbers 0, 2, 4, 6, 8, 10, 12, 14, all the evens, our formula was 2 times I. Our function was 2 times I. And so every single term in this sequence, right, just depends on where it is in the sequence. It's just 2 times its index, where you start at 0. Hope this is making sense. We're gonna do a bunch of examples to really crystallize this. But anyway, here's the point. A sequence has an explicit formula if it can be written like this, where AI equals S5 for all I greater than. All right, so any questions? Awesome. So an example would be if AI equaled 1 over I for all I greater than or equal to 2. This is a sequence. This is the explicit form of a sequence. This describes a sequence. It's just as good as writing the sequence down. In fact, better, because this is just for all I greater than or equal to 2. There is no like upper bound on the I. That means this is an infinite sequence, just keeps going. So we could not even write it down explicitly. We could not even write it down just like normal if we wanted to. I mean, we can write down the first few and say dot, dot, dot. That's what we'll do right here. So what this actually represents is the sequence that goes, okay, so it's at I equals 2. So you have A2 is 1 over 2, right? AI is 1 over I. This is the explicit formula. This is the function right here. Then you get A3 is going to be 1 over 3. A4 is going to be 1 over 4. A5 is going to be 1 over 5. And it continues like that. So this is just, so I mean, if we get rid of the A, if we get rid of these, the sequence is just 1/2, 1/3, 1/4, 1/5, and it goes on and on like that. These little AIs were like those things where you draw a face, where you first make a circle, and then you draw the chin, then you draw the center line, you do that, then you make the eye. Then you gotta erase all that. Yeah, it was like a scaffolding. But anyway, yeah. So this is the same thing as this. And the question we asked last time is, was this the only way that you can write this sequence with an explicit formula? And the answer, what do you guys think? Like, do you like just what's your gut instinct? Do you think that there's maybe a different formula I could use, maybe a different starting point that would give me the same sequence? Or is this the unique way? Is there a one-to-one correspondence between explicit formulas and sequences?
We could actually write it in a different way.
Yeah, exactly, Alfred. Do you know a different way at the top of your head?
It's like if we minus the second one from the first one, we get a difference. And that's the difference between all of them. So the first term minus the difference, we get the second term.
Oh, you're saying like, you look at the difference here, it's going to be 1/2 minus 1/3, which is 1/6. The difference here is going to be 1/3 minus 1/4, which equals 1/12. The difference here is 1/4 minus 1/5, which equals 1/20. Can I work with that?
Yeah.
Maybe you could do something like that, and you could probably do it a slightly different way, but I don't think it would be explicit, actually. A much easier way, but you're totally right that you can do it a different way. A much easier way to do it is, what if you just look at AI equals, like what if the idea is, instead of starting at, so here we start at 2, right? Our first term here is A2. Then we go A3, A4, and we keep going. What if we didn't want to start at 2? What if we want to start at 1, for example? So what if we want to look at for all I greater than or equal to 1? Well, if we do that, then we want A1 to equal 1/2. But that's no longer just 1 over I, but it's 1 over I plus 1. And we'll see that this works. So if we write this out, we get that A1 now, to start at A1, is going to be 1 over 1 plus 1, right? You plug the 1 in for the I, and you get 1/2. A2 is going to be 1 over 2 plus 1, which is 1/3. A3 is going to be 1 over 3 plus 1, which is 1/4. A4 is going to be 1 over 4 plus 1, which is 1/5. And it goes on like that. So notice that we get the same sequence, 1/2, 1/3, 1/4, 1/5, on like that, using a different formula. It's a very similar formula, but it's a different formula. You could also do AI equals 1 over I plus 2. We start at 0. Because that would get you start at 0, you get A0 is 1 over 0 plus 2, which is 1/2. A1 is 1 over 1 plus 2, which is 1/3. A2 is 1 over 2 plus 2, which is 1/4. A3 equals 1 over 3 plus 2, which is 1/5, and it goes on like that. And again, you get 1/2, 1/3, 1/4, 1/5. Because really all we're doing, right, is, if you consider f of I to equal 1 over I, right? The original way we wrote it, this is just the explicit formula is f of I. You start at I is greater than or equal to 2. If you want to start at 1, you kind of have to shift everything along with it. So if you want to start 1 less, you have to shift everything. You have to kind of shift f of I over by 1 to do plug in like f of I plus 1. The point is, right, because we're shifting the starting point 1 back, you have to shift the sequence 1 forward for everything to even out. And here we're shifting the starting point from 2 to 0. We're just shifting starting point 2 back, so we need to shift the what we're plugging into the sequence forward by 2. Does that kind of make sense? So help me out here. If I was going to start at, for all I greater than or equal to -2, what should my formula be to get the same sequence you've been getting here. So now we're shifted back from 2 by 4. We've gone 4, yeah.
I plus 4.
I plus 4, exactly, Afra. See, not that complicated, right? This shifted back 4, so we're gonna take this formula here and just kind of shift it to the right by 4. Or what you plug into it, shift to the right by 4. Yeah, that's it. The point is there's different ways to write it. Any questions on this? So I hope this isn't that complicated, right? I mean, if you look at any, like, there's a lot of writing here. If you look at any individual box, right? I hope you see like, oh, I just have this formula. I just got to plug things in and I get that done. It's not harder than that. Nothing harder than that, right? Just plug things in and you're done. We're just going to talk about some of the intricacies of things, of how there be multiple ways to write things or anything like that. All right, how are we doing? Just good. So, and now let's talk about going the other way though, right? Because for most things we're going to be doing in this class, the sequence might not be given to you, or the explicit form might not be given to you, but instead you might have a sequence, you might have to find the explicit form. So let's see how that would work. So for example, what if our sequence was, actually, let's do one more example when we have the sequence. So another example when we're given the explicit form is, what if we say that AI equals sine of pi over 2 times I for all I greater than or equal to 0. Maybe we should draw a little unit circle here. So what's going on? This is 0, this is pi over 2, this is pi, this is 3 pi over 2, and this comes back to 2 pi. And then remember, this is 1, -1. In terms of height, this is 0. So sine, remember, on the unit circle is like the height. So that's sine of theta. Anyway, what we get then here is that we start at 0. Our sequence is going to be A0 is sine of pi over 2 times 0. A1 is going to be sine of pi over 2 times 1. A2 is going to be sine of pi over 2 times 2. A3 is going to be sine of pi over 2 times 3. A4 is going to be sine of pi over 2 times 4, and it's going to go on like that. So first up, sine of pi over 2 times 0, what's that going to be? It's going to be sine of 0, right? What's sine of 0? Trig is coming back for no reason. Remember, sine is the height, and if our angle is down here at 0, how far off the x-axis is it? Just 0, right? Then sine of pi over 2, well, now this angle is going to go all the way up to pi over 2. So we're going to angle up to here. And now, how high is this point off the x-axis?
90 or 40, no, 45.
Well, remember, sine is not an angle, right? Sine's like a height. right? So sine of pi over 2, which is the same thing as sine of 90, is just 1. Sine of pi over 2 times 2, that brings you down here. The thing keeps going down to pi. And the sine of pi is 0. Sine of pi over 2 times 3, that's going to be sine of 3 pi over 2, so it goes all the way down to here. We add another pi over 2 to it, and then that gets us, how far is that from the x-axis? Well, it's down by -1. And then pi over 2 times 4, add another pi over 2 to the angle, so we go up to here. And how far is this dot from the x-axis? Well, it's on top of it, so it's 0 away. And it goes on and on and on like this. I was hoping, so I'll tell you, what I was hoping to get this example is just plug things in, right? If to go from an explicit formula to what it actually is, just plug things in. That's all it is. Looking back on it, maybe I wish I used an example that was easier than sine. I was hoping sine would be less rusty. But anyway, I hope this tells you that you just plug it in. Like if you had a calculator, you just plug this in the calculator and you get these numbers, and that'd be fun. It's not meant to be any more complicated than that. The point of this is to go from explicit formula to written sequence. Just plug in. All right. Any questions on that? Sorry about the sign confusion. This class is not a trigonometry class. I was just trying to use it. I was just trying to use an example you might know. Maybe I chose wrong. Okay. So the point is, the more fun thing is when you have a sequence, it's like find the pattern. Oh, we have a chat. We got some chat going. Well, that's why I'd rather use it right there for you, Safa. I mean, it's kind of fun. Anyway, yeah, so there we go.